So this video is on dimensional analysis. So we're given a problem, a equal to x times v plus y times t. Now the a, v and the t are all known quantities to us. It's the x and y that are not known. So a is acceleration. We know the units of acceleration are meters per second squared. Velocity is v is velocity, and that's in meters per second. And t, of course, is in time. So that's in seconds. In seconds. T is time, and that is in seconds. So the problem we have to do is to determine or figure out the quantities x and y. So what we'll do is we'll take each one separately. So we know that the units of A are meters per second squared. Okay, so this is meters per second squared. So we know that is the unit here. I know I have x, so I'm going to put x in a big square bracket, and I'm going to put in the unit of meters per second for velocity. Now here's the thing, I can drop the second one for a moment, you should say, purely because if I'm going to add this quantity to this quantity, then the only way I can add them is if they have the same units. So that means, by default, they have to have the same units. In other words, you cannot add 2 apples to 3 oranges. To put it like that, you simply can't add them. You would have to change the unit to something they all have in common, just pieces of fruit or something like that. In this case, this quantity, the whole thing together, must have the unit of meters per second squared. Okay? So I'm just going to leave this as x. The units of x are going to be, it's going to be meters per second squared on this side. And I know I have meters time divided by seconds on this side. Okay. So at this stage, I can actually kind of cancel some of the units off. So I have a meter on this side, and that will cancel with a meter on this side. And I have a second on this side, and that will cancel with one of the seconds on this side. So what that means is that the unit of x, don't know what it measures, but it seems to have a unit of 1 over seconds. So it looks to be a quantity like frequency, which would be seconds to the minus 1. Okay, so that's the first one sorted. So I know that x has a unit of meters, of just seconds to the minus 1. I'll do the same thing for y now. Okay, so again, I'm going to set it up the exact same way. I'm going to say that acceleration is equal to the quantity, or the quantity, I guess, or the unit of y times t is the same as the unit of acceleration. So that's y. Again, I'm going to put a square bracket on it, times t. Time, of course, is measured in seconds. This one is measured in meters per second squared. And I've got y left here. Okay. So that means I can now apply a little bit of algebra to it. So the quantity y will have units of, well, if I divide on this side by a second, then that will get rid of this one, but that means I also have to do the same thing on the other side. That gives me meters per second to the power of 3. Okay. So this is a kind of a funny looking unit, but it's a quantity known as jerk, which is a rate of change of acceleration. bit of a funny one. Now what we'll do is we'll just double check them. So let me just come back to my original equation. Okay, the original equation said A equal to x times velocity plus y times time. I'm going to plug in all the units here and they should cancel out. So I know on this side I have meters per second squared, because we know that that is the unit of acceleration. I have figured out that the unit of x is 1 over seconds, or seconds to the minus 1. I know the unit of velocity is meters per second anyway, plus I have a y term here. I've determined, or I've figured out, the unit on my y quantity, whatever this is meters per second cubed. And I know that the unit of time carries the unit of second, or the quantity of time carries the unit of second anyway. So now if I just kind of follow them through for a little second, this quantity I have, if I multiply them, then I get meters per second squared. And this quantity, well, this one will cancel with one of these and leave 2 over, and that also gives me meters per second squared. So my answer is going to be meters per second squared. This one is in meters per second squared, and this one is in meters per second squared. So I know I've done my job right. Okay? I hope that helps.